This is lesson 8.7. In this lesson, we're going to learn how to factor what we call a difference of squares. This is a special type of factoring. So we're not using a C method here. We're not using like factoring out a common factor. This is actually the reverse of something that you've already learned before back when we did foiling. Okay, so here we can recognize a difference of two squares to find the zeros of functions. So remember, first we learned how to do foiling for a question like this to find the product. So whenever it says to multiply, you actually want to FOIL. So we'll do first, outer, inner, last. So m squared minus 2m plus 2m minus 4. And then here, this would simplify to, this would cancel out, so then you would have m squared minus 4. And then that would be the answer for that one. So if you remember, when you have two products and the first one is positive and the second one is negative, then the two middle terms cancel out and you were left with two terms. Now this is called a difference of squares. Difference of squares. Because the first term and the second term should always be perfect squares. So if you took the square root of them, they would come out to be whole numbers. All right, for this example, you would have s squared. I'm going to do that one in green. S squared, and then this would be minus 2st, and then this would be plus 2st, and then the last term would be minus 4t squared. And once again, the 2st's cancel out, and you're left with s squared minus 4t squared. So another important part of the difference of squares is that it's not the addition of squares, it's the difference of squares. So it should always be subtraction in the middle. All right, for number 3, this would be 16x squared, and then minus 20x plus 20x, and then minus 25. So if you recognize that the outer and inner terms are going to cancel, then you don't need to write them. So if you know the pattern, then you can use the pattern. 16x squared minus 25, that's difference of squares because 16x squared and 25 are all perfect squares. Okay, so the pattern we saw was if you have two binomials that are the same and you're multiplying them, but one is positive and the other one is negative, then the outer and inner terms are going to cancel. You're just going to have the first squared minus the last squared. All right, so here's a little note for you. The final answers in numbers 1 through 4 are called a difference of squares. We can rewrite them in factored form in order to find the zeros of the function. So now we're going to be working in reverse. So if you have a difference of squares and you want to find the solutions, you'll need to factor them. So in order to factor a difference of squares, you write it as a minus b times a plus b, where you take the square root of whatever a and b are, and then you write those in the parentheses. So they must be perfect squares, and you must have subtraction. So let's look at the first example here. We're not going to do all of the examples, but